How are you? Thank you for coming to the NGK BRP Iridium presentation. My name is Jeff Sova. I'm with NGK and I'm the Business Development Manager for them. Today we're going to talk about common issues in the marketplace that you may find with your customers coming inside to your dealership. Some of the common issues you will see or will find customers relaying to you is uneven throttle response, complaints of rough idling, trouble starting engines in cold weather, premature plug fouling, big issue, and also excessive gap growth. The solution for all of this is the NGK Iridium program. In brief, how did all this get started? NGK wanted to start by bringing a performance plug to the marketplace. Now obviously a performance plug means a smaller center electrode. Now we can do this by reducing the size of the current 2.5 millimeter electrode on a standard spark plug and reduce it to a 0.6 millimeter electrode on the Iridium. However, we tried doing this with a nickel. It did not work. The performance level was there, however the longevity and the lifespan of the plug was not. So then we decided to go with different precious metals. The different precious metals also had two things we had to keep in mind within the combustion chamber itself. The two deadliest killers for spark plugs: temperature or heat, as well as oxidation of the product itself. When we looked at different precious metals, we also tested them in a sealed, pressurized container. The container itself was at room temperature, and we were cycling electrical current within the test spark plugs with different metal tips, or different precious metal tips I should say, for 200 hours. After the 200 hours of the simulation, we measured the gap growth. The gap growth itself was then brought forth to the other side of the fence, where we also measured the heat dissipation properties of the metal, as well as the oxidation properties of the metal. We noticed that oxidation-wise, Iridium was by far the more superior of all the products. Temperature-wise, tungsten was. The best scenario for both issues together was using an Iridium-type program with a precious metal tip of the electrode. We also brought in new technologies into the marketplace for the performance aspect of the plug. And this is a two-stage insulator device, or an anti-fouling device, for lack of a better term. This anti-fouling device, the way it works, if you picture the cone of a spark plug, as the emissions burn off in the combustion chamber, they naturally coat the inside of the spark plug or the cone itself, and the carbon starts building up. The two-stage insulator device adds that extra layer or a little air gap. So once the carbon starts going up to the top, you'll have a secondary micro discharge around the top of the spark plug, right around here, where the carbon is going to start burning off. The plug is non-restricted and will keep functioning. The telltale sign of these two items: on a conventional spark plug with a 2.5 millimeter electrode, the spark plug will be black, carboned up, and will not fire properly. You'll get misfires in the engine. The Iridium, with this two-stage insulator device and an anti-fouling built in, you will see the spark plug will be black, mind you. However, you will have a white circle on the very tip of the electrode. That is a telltale sign the electrode and the spark plug is firing properly. The other aspect and technology we brought forth with the high-performance spark plug, or the Iridium program, is a taper cut design on the base strap electrode. The gap between the center electrode and the base strap electrode is preset. Yet what we want to do is reduce the quenching effect. And by tapering this particular base strap electrode, we actually increase the amount of detonation power from the limited electrical discharge. The quenching effect, in essence, quenching is the loss of heat energy from the flame to the electrode of the spark plug that would otherwise contribute to the combustion of the fuel mixture. The Iridium program, by reducing or by cutting the base strap electrode, is actually increasing the amount of electrical discharge. And then by increasing the amount of electrical discharge, you get a better combustibility and better fuel economy within the cylinder itself. Therefore, more performance, less problems. So, as they say, seeing is believing. This is a brief video on exactly what happens inside the combustion chamber using the particular spark plugs. On the one side, we are going to have the nickel 2.5 millimeter electrode, and on the other side, we will have the Iridium 0.6 millimeter electrode. Again, the power of the spark. You can see the way that the spark itself is dancing around the 2.5 millimeter electrode. So there's a lot of lost electrical energy there for combustibility. On the iridium side, it's very concentrated, very tapered, low energy, and much better performance. On the combustion side of things, using the same theory, on the one side, you'll have the speed of the detonation. On the iridium, you have that speed. The speed is about 30% greater. Better combustibility equals more performance and a high output, less issues. So you have an engine that starts faster, especially in cold weather. You have more efficient and improved fuel economy, more power, a true performance plug from NGK Iridium. What we also did, we teamed up with Bombardier. BRP has, with NGK, an alliance where we will actually give you a auto ship program which is 100% guaranteed. We will ship you between 8 and 20 units with a dealer kit. For any reason, keep the dealer kit, by all means. The dealer kit itself will include a countermat of an NGK Iridium explaining all the benefits and features of the particular product. You'll have a push-pull sticker for your front door for your consumers, trifold brochures to further explain the advantages of the Iridium program, as well as a die-cut sticker. I thank you for your attention and good selling.